Right, so if we look at this question here, we're looking at depreciation in this case. So a car decreases in value 10% each year, and it does that for 2 years. It starts off with £5,000, a value worth £5,000, then it goes down by 10% each year. So the first thing we want to, we'll look at it the slow way, and then we'll look at how to speed it up, and then we'll look at a different question and do that the fast way. So what we did the slow way is we worked out, well, what is 10% of 5,000? It's 500. So at the end of year one, it would drop to 5,500. Now be careful here, you nearly fell for this trap. You thought, well, end of year two, it's going to drop another 500 and it would go down to 4,000. But no, that's what they're looking for. They're trying to trap you there because it's the 10% in the second year will not be of 5,000. It will be of the amount that it is at the beginning of the second year, which is 4,500. So it dropped from 5,000 to 4,500 in year one. So at the start of year two, it's 4,500, and it's going to drop another 10%. But it's 10% of 4,500. Now, 10% of 4,500 is 450. So we're going to be taking away 450 from 4,500 to get 4,050. How did we work out the percentage in the first place? Well, a lot of people know that 10% is a tenth. So they might just divide it by 10. That would work. But that doesn't teach us what to do if we have more awkward percentages, like, I don't know, 13.7 or something like that. So instead, a better way to think about it is you take the percentage, like 10% or 13.7, and you're dividing it by 100, you do 10 divided by 100, but really, because you're dividing it by 100, you just shift the two places to the right. We actually did some examples up here, didn't we? So 87% becomes 0.87, 10% becomes 0.1, and 2% becomes 0.02. So we're shifting the numbers once, twice to the right. So the 1 once, and then behind the decimal point, and then the 0 would go after here, but we don't need to worry about that one. Okay, so that's how to do it the slow way. Now, the fast way, the first tip for the fast way is to, rather than work out how much is it decreasing by, what is it decreasing to? So if it's decreased by 10%, it's decreased to 90%. It's now 90% of its original value. So rather than multiplying it by 0.1, we'd multiply it by 0.9, and so we've skipped a step now. So we've got it down to, we've looked at this and we see that, it's going to be, therefore that's the amount at the end of the first year. Do the same thing for the end of the second year. That's made it a little bit faster. Here we go. Where have I got it? I skipped a bit. 5,000. Oh yeah, here we go. Yeah. So working out the 10% of for year two, we started off with 4,500, and we got it down to that, and the same with year one. Okay, so I didn't make that very clear. We've got it, so because we kind of worked backwards. So that would be the end of year two, that would be the end of year one. Now, so what we can then do is we can see that to work out the 4,500 from year one, which ends up being 4,000. Sorry, to work out the amount for the end of year one, we'd multiply by 0.9, the original amount by 0.9 to give us 4,500. So that's what we got up here. So in other words, that is the same as that, because as you can see. So instead of, to work out the value at the end of year two, instead of multiplying by 4,500, we could just imagine multiplying it by that. Let me just try that again. Yeah. So now we can see basically what we've got is the original amount multiplied by the amount it would drop to, the percentage it would drop to, and it's going to do that both years. So it'd be 0.9 times 0.9 or 0.9 squared. Incidentally, if it dropped a different percentage and the other year, let's say it dropped by 20%, it'd be 0.9 times 0.8. It's the same percentage, it's a little bit easier. Okay, let's imagine if it was the numbers were different. So I'll do this over on the left-hand side so we can see the numbers, and you won't be able to see exactly everything I've done there, but actually no, what I will do first is I'm going to come up with a formula from that. So I'll say what shall I say? Let's say the interest is the amount it drops by or increases by, and in this case it's negative 10% because it's reduced. Okay, which is the same as negative. Let's write that again. It's the same as negative 0.1. We'll say the S for the starting amount, and there's probably using different symbols on the internet if you find a formula like this. And it might be a tiny different version to this, but it's going to be the same. It works out to be the same thing. So S is going to be the starting amount, £5,000, and we're trying to work out the final amount, which we worked out to be 4,050. So what we can see here is that the final amount can be calculated by the starting amount multiplied, and this is the key bit, it's actually not the interest, but it's 1, and it's actually plus the interest, even though I took it away, but that's because the interest was negative. 1 plus negative 0.1 would be 0.9. Oh, and then you do it to the power of the amount of time. So the time in this case is 2 years. You must do it in the unit they're referring to. So that's to the power. Well, we're keeping it in symbols. It's to the power of t. Okay, so that's the formula that we've kind of derived there. We've kind of come up with, and using that formula is going to make it a lot faster. So, but it makes the maths harder. Like trying to understand that formula is harder. But if you just rewatch that video a couple of times, then hopefully it will make a bit more sense. So, and the other thing about this, by the way, is you can rearrange this formula, which is quite useful. So, okay. So let's say that instead it decreases. Let's say it increases in value. Let's say it's some sort of antique car. Okay, so it increases in value over time, and it increases by, let's say, 5%. And when it was first bought, he bought it for £700. And I'm not going to say I'm going to say no. Let's keep it at 5%. That's fine. And we're not, rather than doing 2 years, we're going to say keep the numbers all different so it's not confusing. Say 4 years. Okay. So what would it be worth? Well, we say the final amount is going to be equal to the initial amount, the starting amount, which is 700. And then we multiply that by 1 plus, and we do plus it this time because it's a positive percentage. 0.05. So I should have, I'll make this a little bit clearer in a moment. And then to the power of 4. So in other words, starting amount was 7. There it is. There it is in my working out. The percentage is 5. There it is. And I think I need to make that a little bit clearer by writing positive, not negative. Well, just leaving it. I guess I could write a positive 0.05 because that's what 5% is. And I can highlight it there and highlight it there. And then we will do a bit of blue. And that's the amount of time, which is 4 years. So, basically, I'll do it this way. Actually, I was going to do it for a smaller amount, and then we could actually do it the slow way to show you got the same answer. But Shall I do that? Yeah, I will do that. I'm going to keep it as 2 years, the same as before. So the time is actually 2 this time. Just because I want to do it the slow way and then show you that we still get the same answer. So, okay. Right, so 700. So let's just put that into our calculator now. So the great thing about this as well is you only have to pick up your calculator once and tap it all in one go. Again, that saves you time in your exam. So 1 plus 0.0. I mean, I could have worked that out, couldn't I? 1.0.05. Sorry, 1.05. Anyway, squared. So that means that after 2 years, my car is increased in value because it's some sort of classic car or something. As long as I look after it, it's now worth that much. Now, let's just see if that is correct doing it the slow way. So let's think about this. Year 1, at the end of year 1, it would have increased by 5%. So 5% of 700, well, that's going to be 0.05 times 700. So what's that? 700 times 0.05, that's 35. So 35, yeah, should have written the symbols really. But anyway, so the end of year 1, we have, it's going to be 700 plus 35, so 735. Year 2, we're going to add another 5%, but this time of this amount, so 0.05 times, 735. So 735 times 0.05, and that gives me 36.75. That's looking good so far because we've got the 7.75 there. Let's add some pound signs. And then we're going to add that to the amount that was at the beginning of year 2 or the end of year 1. So we add it to 735. Yeah. And we get that value. Okay, so you can see that was much slower, but it does obviously give us the right answer. But if you understand that method, it's much faster. And also, it has the advantage that you can do it for, if I did it for, what would it be after 20 years or 25 years? You're not going to do the slow way then. You're going to be here all day trying to work that out. Doing it this way for a long period of time, then it enables you to do it. You're probably going to get questions like that in the higher tier if it was like multiple years. Okay. Anyway, I hope that was useful.